Dr. Alberto Villoldo. In the mid-1950s, American neuroscientist Paul D. Maclean proposed a model to help explain the evolution of the human brain. Maclean's model became known as the triune brain, and it describes how we have three evolutionarily distinct neurocomputers, each with its own intelligence, subjective feel of the world, and sense of time and space. Maclean's model is too general to be of value to students of evolutionary anatomy, yet it is helpful to metaphorically understand how each of us reacts differently to situations, depending on the brain we are responding from. It explains how, when we smell the scent of wolf, one of us may sense danger while the other may detect opportunity. The first brain is the reptilian brain, or our brain, which is anatomically very similar to the brain of modern-day reptiles. This brain region is completely instinctual and primarily interested in survival. It regulates most autonomic functions, such as breathing, heart rate, and body temperature, and it is involved in the fight-or-flight response. There is nothing cuddly about a reptile, and this brain region, like a cold-blooded serpent, feels no emotions. The second brain is the limbic system, which is made up primarily of the amygdala, hypothalamus, and the hippocampus. Maclean described this as the brain of instinct and emotion. The limbic system is also known as the mammalian brain, or AM-brain. As the name implies, this is the brain most dominant in mammals, which flourished about the same time that dinosaurs were staving off extinction. As such, it represents one more step in the ladder of evolutionary complexity. In the limbic system, signals are decoded according to four fundamental programs, known as the 4Fs: fear, feeding, fighting, and fornicating. The M-brain will interpret meeting a person for the first time as an individual to be wary of, a dinner date or promising business partner, a potential adversary, or a possible mate. This brain also interprets color according to the cultural environment that programmed it. Red, for example, means danger, stop in the United States, but it means good fortune to the people of China, and best or beautiful to Russians. To better understand how the M-brain functions, let's look at the structures within it that evolved to ensure our survival. The limbic brain contains the almond-shaped amygdala and the seahorse-shaped hippocampus. Both are involved in processing information from our environment via our emotions. The amygdala, from the Greek word for almond, governs our fight-or-flight response, which is our automatic and instantaneous reaction to real or imagined threats. Basically, it's the fear center of the brain that allows us to respond to dangerous situations reflexively, unconsciously, and immediately. If an enemy ambushes us, we become terrified and fight or flee. If a snake strikes out at us, we instinctively jump away. The hippocampus is in the deepest and most forward portion of each medial temporal lobe and extends into both hemispheres of the brain. It was named by 16th-century Italian anatomist Julius Caesar Aranzi, who noted its uncanny resemblance to the seahorse and chose the Greek word for this creature. Early researchers believed the hippocampus was involved with the perception of smell, no doubt because it is located near the olfactory system. Even though studies later showed that olfaction was not a primary function of the hippocampus, researchers continued to explore the relationship between the memory of sense and hippocampal function, such as how a certain smell will remind you of a childhood event. Recent research, however, reveals that rather than serving as a storage center for memories, the hippocampus acts more as a way station, acquiring information from the five senses and then parceling out the data for processing either by the amygdala, in the event of a perceived threat, or to the cerebral cortex for all other needs. In effect, the hippocampus operates something like a digital camera that can process both still pictures. Recalling facts is termed declarative memory. Events, like video, are more complex and involve relationships that are both spatial as well as temporal. This mental activity is called episodic memory. When the hippocampus begins to deteriorate, new experiences are less likely to be stored and memorialized, and this is a hallmark of Alzheimer's disease. Advanced imaging techniques like MRI and PET scans can clearly show that loss of physical tissue as well as loss of function in the hippocampus is an early indicator of this disease. The hippocampus begins to fail due to free radical and chemical damage caused by certain foods, Trauma and stress. Conventional wisdom tells us that once the hippocampus begins to fail, the ability to process information through higher brain centers is stunted, that our emotional repertoire is diminished, and that genuine feelings become inaccessible. The good news is that when we combine an ancient shamanic healing discipline with cutting-edge neuroscience, we can actually heal disease before it manifests in the body. We can reprogram our biological destiny so we don't have to relive the illnesses and dramas that run in our families. We can create extraordinary health for the rest of our lives. In an upcoming blog, we'll discuss the new brain, the third section in Dr. Maclean's triune brain model. Let's block ads. Why?